All right, let's just jump right in. Today, we're talking about one of the most powerful, and honestly, one of the coolest techniques in web automation, XPath axes. Seriously, this is a total game changer for finding those super tricky elements on a web page.
You know that feeling, right? You're writing a test, everything's going great, and then bam, you hit an element, a button, a link, whatever, and it has no ID, no name, no unique class, pretty much nothing to grab onto.
Yeah, it's one of the biggest frustrations in automation. You just can't move forward because you can't reliably tell your script what to click on. It's a complete roadblock.
But this is where things get really interesting. What if you could tell your script, hey, go find that input field that's right next to the username label, or click the button that's inside that specific form? Well, that is exactly what XPath axes let you do.
So, to really get how this works, we've got to think of a web page less like a flat document and more like a family tree. This one idea, this analogy, it unlocks everything. So, whenever your browser loads a web page, it builds this thing called the Document Object Model, or DOM for short. All it is really is a big map, a hierarchy of all the elements on the page. And once you understand the relationships in this map, you can get from anywhere to anywhere else. Every journey needs a starting point, right? In XPath, we call this the self node. It's the one element you can find easily. It's our anchor, our "you are here" sign on the DOM map. And from here, we can go anywhere.
Okay, so from our starting point, we can look up. Just like in a family tree, every single element has a direct parent. That's the container it's sitting inside. And here's the key. There's only ever one. That makes moving up the tree incredibly predictable. And of course, if you can look up, you can also look down. From our starting node, we can find its children. These are all the elements nested directly inside it. And unlike a parent, an element can have lots of children, which is how the tree starts to branch out and get complex.
Now, any elements that share the same exact parent, we call those siblings. Thinking of them like this, like brothers and sisters, is the whole secret to navigating sideways, moving from one element to another on the same level of the tree. And this same logic lets us make some really big jumps. An ancestor is just any node above our element, the parent, the grandparent, the great-grandparent, all the way up. And a descendant is any node nested below, a child, a grandchild, you get the idea. This is how we can travel multiple levels at once. Okay, so we've got the whole family tree analogy down. It makes sense, right? Parent, child, sibling. But now, how do we translate those ideas into actual code that our automation script can understand and use?
You know what? The syntax is surprisingly simple, and it's always the same. First, you start with the XPath for the element you already know, that's our self node. Then you just add a slash. You type the name of the axis, like parent or child, then 2 colons, and finally the type of element you're looking for. That's the whole pattern.
Let's look at this in action. It makes it so much clearer. In this first example, we find the username input, and then we just say /parent/form to travel up to the form it belongs to. Easy. In the second one, we start at that user dive and use /child/input to travel down and find the input field inside of it. See? It's a very direct, very logical way of navigating. So finding parents and children, that's useful for sure. But the real superpower of XPath axes, the thing that lets you solve those really impossible locator problems, comes from navigating sideways and in more complex ways. Now, this brings us to something that trips a lot of people up. The best way to think about it is sledgehammer versus scalpel. The following axis is a sledgehammer. It grabs every single node that comes after your element anywhere on the page. But following sibling, that's a scalpel. It precisely selects only the brothers and sisters that come after it. Trust me, 9 times out of 10, the scalpel is what you really need. And here it is, your quick reference guide, your cheat sheet. We've got axes to go up, like ancestor and parent. We've got axes to go down, like descendant. And we've got axes to go sideways, following sibling and preceding sibling. This table pretty much covers the essential commands you're going to use every single day. So, we've covered the theory, we've looked at the syntax, but let's talk about why this all matters. How does knowing this stuff actually make you a better, more effective automation engineer? Get this. According to our source, a whopping 70 to 80% of an automation engineer's job can be spent just trying to locate elements. I mean, just think about that for a second. If you can get really good at this one skill, you can massively speed up your workflow and get rid of your single biggest bottleneck. Well, the benefits are just huge. You can finally target those elements that everyone else calls unfindable. Your tests become way more robust, way less flaky, because they depend on the structure of the page, not on some fragile ID that a developer might change tomorrow. You're basically creating locators based on stable relationships, and that is the key to unbreakable tests.
And this quote from the source material just nails it. This is the whole philosophy in a nutshell. Use what you know to find what you don't. Use a stable, boring, easy-to-find neighbor to locate a tricky, unstable target.
So now, this is a new tool in your toolbox. I want you to think about that one element that's always given you trouble, or that one test that's always been flaky. With XPath Axes, you have a brand new way to attack that problem. So my question to you is, what impossible element will you locate first?